Hi guys, my name is Terry. In this video, I'm going to go through with you additional mathematics form 5 textbook question for chapter 8 kinematics of linear motion formative exercise 8.4. Yeah, if you enjoyed this video, kindly like, subscribe, or leave us a comment. So let's get straight to the first question. So a cricket player hits a ball and travels along a straight path through C with a velocity of 44 meter per second. Acceleration is given by this A equals to 12 minus 6D. Now we're calculating the maximum velocity. Now we know maximum velocity happens when A is 0, when you cannot increase your velocity anymore. So for example, in this case, maybe I just draw like this. You increase your velocity until you can't increase anymore. Yeah, maximum happens when the gradient of the velocity time graph is 0. In this case, A is 0. So let A be 0 and solve for t. 6t is now 12, t is now 2. Okay, so once you got the value t, we need to sub this inside your velocity function. But the problem is I do not have the velocity function. So I have to integrate acceleration function to find your velocity function. So in this case, if you integrate 12, you add a t, 12t, integrate 6t, increase the power by 1, t squared, 6 divided by 2, I got 3 plus c. Now, initially, when you start the clock, yeah, the velocity of the ball is 44. Okay, v equals to 44. So when we substitute 44 inside here, t is 0, 0, c is just 44. So my velocity function is 12t minus 3t squared plus 44. Now take t equals to 2 and sub inside. When t equals to 2, the ball has maximum velocity, and that velocity is 12 times 2, 3, 2 squared plus 44. This is 24 minus 12. This is 12, which is 12. 12 plus 44 is 56. All right. Next one. Find the distance of the ball from the center P when t is 2. Okay, to find distance, we have to first find the displacement function. So displacement function can be obtained by integrating your velocity function, 12t minus 3t squared plus 44 dt. So when you integrate 12, you get 12t, you get t squared divided by 2, 12 divided by 2 is 6. T power 3 divided by 3 is t power 3 here, 44 t plus c. When t is 0, what is your s? Well, because the ball starts to move from a center P, and normally we say O, but in this case they refer P as your starting point or your origin. So your s is also 0, therefore your c is 0. So my displacement function is 6t squared minus t cubed plus 44t. And to find the distance when t is 2, very simple, we sub t 2. You will get s equals to 6. 2 squared, which is 4. You can write 4 straight away. Then 2 cubed, which is 8 plus 44 times 2. This will be 24 minus 8 plus 88. So basically 24, 88 plus 16, I get 104. By the way, you can also use definite integral because sometimes when you use displacement function is a bit long because you have to find this first and substitute. The alternative method will be, we can say the distance as integration 0 to 2. 6, integrate the original velocity function. Velocity function is this 12t minus 3t squared plus 44 dt. And then from here, increase the power by 1. This is 6t squared, t cubed. Now, basically, this is the same as this line here, as you can see. Yeah, after integrate, we just have to substitute, and you get answer 104. Now, the good news is we can use a calculator to validate the answer. Okay, let me just show you over here. We integrate. The original function is this 12t, 12t minus 3t squared. In this case, you're using t, we use x, because your calculator doesn't have the t function, we have x instead. So this is 0 to 2, and then there you go, 104. Yeah, same answer. So please show your substitution and you get the answer. Yeah, the substitution is actually this. Because if you sub 2 inside, you minus 0, the whole thing is still 0, isn't it? right? So it's just the same as if you were to write this. This is the same, exactly the same as the one above here, 2 squared, 2 cubed plus 44, just minus 0, you will still get 104. All right, that is all question number 1. Moving on to question number 2. An object move along a straight line from fixed point x. Acceleration is also given as this. Notice that the law of question like acceleration function here. Your a is 16 minus 40. Okay, given the velocity of the object at t equals 3 is 38. Calculate the initial velocity. Okay, first of all, if you want to find initial velocity, you find your c here. But first, we need to integrate acceleration. When you integrate acceleration, you get velocity function 16t. This is what? 4t squared over 2, 4 over 2 over 2, t squared plus c. Now we know when t is 0, what's your v? Your v, okay, I can't use t equals 0 because I don't know that. Instead, I am given t equals to 3, v is 38, right? When t equals to 3, v is 38. So we are finding the value of c now, yeah? Let's put 38 inside. Let's put 3 inside. This is 3 squared. I'm going to write 9 to make my calculation easier. So this is 48. 48 minus 18 is 30, plus c. Bring over my c is just 8. Okay, now c basically represents your initial velocity, but let's just rewrite this first. 16 equals to t, 16, v is 16t minus 2t squared plus 8. When you start the clock, t is 0. What's your v? Your v is 8. Yeah, this is your initial velocity. Okay, next one. Find the velocity in the 4th second. Very simple. In the second, t is just 4. Your v is 16 times 4 minus 2, 4 squared plus 8. So this is 64 minus 32 plus 8 gives us 32 plus 8, 32 plus 8, which is still positive 40 meter per second. All right, yeah, this is still okay, not difficult. Moving on to question number 3. So object A and B, they are placed on the horizontal line. A toy car moves along a straight line. Velocity of the toy car after passing through point A, after pass through object A is given by this B equals to 2t minus 4. At the beginning, car moved towards B. Okay, so here's the thing. You need to understand that when they say at the beginning it moves towards B, so meaning when t is 0, your v is negative 4. So what does that tell us? That means the object is actually, the toy car is actually moved to the left. So this is your B, object B, this is your object A. The toy car is here. It is moving to the left from A to B. Okay, so now let's calculate the range of values of B when toy car moves towards B. So here we should say your V is less than 0. I can tell that it's going to the left because when you sub in t equals 0, your V is negative 4. So it's actually moving to the left, not to the right. Okay, let us take your V here, sub inside, and solve for t. 2t is less than 4, t is less than 2. Okay, so there you go. Now the textbook answer, just give the answer as t less than 2. But actually, by right, guys, by right, we should say that when you start the clock, t is greater equal to 0, then we should add in this, yeah, by right. But I think this is the textbook answer. I think this is good enough, right? We know time is always positive, right? So we let t be greater equal to 0. Now, one thing to test, you ask yourself this, to test the validity of this answer is that when you start the clock, whereas what is the velocity? The velocity is negative 4. Isn't it negative? Yeah, it is negative and it's moving to the left, right? So for the first 2 seconds, right up to the second second, doesn't include the second second, yeah, the toy car is moving to the left. Okay, let's move on to part B. Given that the distance between A and B is 5 meters, determine whether toy car can reach B or not. Okay, very simple. We know the particle, or in this case, the car changes direction when V is 0. Yeah, when just let V is 0, we know D must be 2. I don't have to recalculate this because just imagine I put 0 inside, D is 2. So we're going to find how far it goes to the left. So we need to take this D equals 2 and sub inside your displacement function. The problem is I don't have a displacement function, right? So we need to integrate V to get your S. So this will give us t squared minus 4t plus c. Now remember, when you start the clock, t is 0. Where's the object? Where's the car? The car is at point A. So we treat point A as the starting point, as your point O if you like. So your c is also 0. And your displacement function is now t squared minus 4t. Okay, let's take t equals 2 and sub inside. Okay, that would be able to let us know whether it would actually reach point B. This B is 5 meters from point A, yeah, but it's 5 meters to the left. Okay, so we put 2 inside. Your S is now 2 squared, which is 4. 4 times 2 is -8. So 4 minus 8, -4. So this is not, it's not less than -4. Yeah, -5. Yeah. Should I say the distance that it traveled is just the distance traveled is 4, which is less than 5 meters. So we say that toy car, whether the toy car can reach, cannot reach, yeah, cannot reach or does not reach object B. I does not reach object B. Okay. All right. Let's look at the total distance travel. Okay. Total distance travel in the first 6 seconds. I already know that it changes direction with d equals to 2. So I can do a sketch. Okay, you can sketch the whole velocity time graph if you like. Yeah, we know that the velocity in this case is 2t minus 4. It's actually a straight line, a very simple straight line with a positive gradient, right? And the y-intercept is at -4, x-intercept is 2. 2t minus y equals 0. So we know particle changes direction at t equals 2. So this is 0 to 2, 2 to 6. So your distance will be area under the graph. Okay, you can do that. Or you can just use your displacement function. Yeah. You see that? I already have my displacement function, so but I know it changes direction here at 2. So we can say the total distance travel. Okay, first part up, we can say it is S2 minus S0, and this part is negative, so I modulus it. Then you plus with S6 minus S2. Now, S2, I already have it, it's -4. Your S0 is just 0. S6 is very simple. We substitute 6 inside here. It gives us 6 squared minus 4 times 6. And S2, another -4 once again. So this is -4 modulus. This one will be 36. 36 minus 24, 12. 12 plus 4, which is 16. So total distance travel is 20 meters. All right. Now, next part D, we need to draw the graph. Okay. Okay, we're drawing a displacement time graph. Okay, so the displacement time graph in this case is a quadratic. Yeah, look at this. Very simple. We can let S be 0. Your T, and I factorize directly. Yeah, I factorize this is a simple quadratic equation. Let it be 0. T is either 0 or 4. Now we know that your A is more than 0. Yeah, A means in this case the coefficient T squared. So it's a smiley face graph, right? Like this, it goes down and up, okay? And then we draw the axis, it goes across like this. Okay, maybe I draw a bit bigger because that's in 0 to 4. Okay, I think it's okay. I think it's fine. I think this is fine, okay? It's big enough. So we draw this way, Now this is your vertical axis, your displacement. Okay, all right. Line is not very straight, but it's okay. All right, so this is your displacement, and this is 4, this is 6, this is t. We know that we got all the information that we needed, because we already know that the particle changes, that the toy car changes direction when t equals to 2. Initially it goes to the left, and then it reaches a maximum distance to the left of -4. So it never really reached point B. It just go to the left by 4, and then it makes a U-turn. It returns uh, to point A at t equals 4, and then it goes back to the right, and it travel up to another. This is previously I calculated this. This is 12, so this is S6. S6 supposed to be 12. Okay, you count this again. S6, that's 6 squared 36. 36 minus 24 is 12. So notice that we actually go to the left. Let me use a red pen. It goes to the left by 4, and then it goes back up to the right by 4 plus 12, which is 16. So your total distance traveled is actually 20. Yeah, it matches this answer earlier. So you're drawing displacement time graph from 0 to 6. Well, we're done. Yeah, that's about it. We don't have to do anything. Okay, my graph is done. All right. So let's move on to question number 4. Okay, an experiment is conducted, yeah, to see, to study the motion of particle along a straight line. So with velocity of v, okay, the velocity function is this. The beginning of experiment particle is 2 meters to the right of point O. Calculate the distance when v is 5. Okay, so I already have my velocity function. I need to find my displacement function and sub inside. Okay, you can actually integrate, use definite integral, but I see that I will need to find the displacement again later on. So maybe we find displacement function first. Finding displacement function from velocity function requires us to integrate your velocity. So in this case, when I integrate this, I get t power 3 divided by 3. This is t power 2 divided by 2. A divided by 2 is 4. There's a 4t plus c. Okay, so when you start the clock, the particle is 2 meters to the right O. That means when t is 0, s is 2, right? Picture this, 2 meters to the right is positive. So 2, this is 0, 0, 0. What's your c? Your c is 2. Therefore, my displacement is t power 3, 4t squared plus 4t plus 2. Okay, so this is my displacement function. All right, I need to sub t with 5. Let's put 5 inside. 5 cubed, I'm just going to use cubic directly. 1 to 5. 5 squared, 25. So 4 times 5. Yeah, 20. So this one is 25 minus 100, which is 25. 25 plus 20. So that would be 45. 45 plus 2. You should get 47. Yeah, 47. Okay, this is only part A. Let's do part B, minimum velocity. Now we know we will have a minimum velocity when your gradient A is 0. Gradient of velocity time graph is the acceleration. Acceleration is 0. So, but first I need to differentiate V to get my A. So when I differentiate, I get 6t minus 8. Yeah, differentiate 3t squared. 2 times 3 is 6. Copy t, reduce the power by 1. Differentiate negative 8t is minus 8. Let A be 0 and find your t. 6t equals to 8. T is 4 over 3. Now take this 4 over 3 and sub inside your V. So V will give us a minimum, right? When t is 4 over 3, you square it, minus 8, 4 over 3 plus 4. Okay, this is 4 squared 16. 16 divide 9, cancel 9, 16 over 9 minus 32 over, sorry, 16 over 3, I cancel 3, 3, 16 over 3, 32 over 3 is 16, negative 16 over 3. Negative 16 over 3 is 5, 1 over 3. Yeah, 5 over 3, you plus 4, is -1/3. Yeah, you're not sure, you can just use your calculator. Just type in your calculator. Yeah, you'll get this answer. Okay, C. I try to reserve some space to do part C and D. Find a range of time when the velocity is negative. Well, when your velocity is negative, we take this 3t squared minus 8t plus 4, let it be less than 0. So this is a quadratic inequality. So we can factorize that. 3 times 4 is 12. Factor of 12 will be 6 and 2. This is 6. Let me use 6 and 2. I hope you know how to factorize very quickly by now. Yeah, not just using calculator. So minus and minus. So we can tell that the roots should be 2/3 and 2. Yeah, this is a velocity time graph, the sketch of the velocity time graph. Now, in order for the velocity to be less than 0, it should be below here. Let me just use a different color, green. So, okay, your p-value should be anything between 2/3 and 2. All right. And finally, part D, find the maximum displacement from point O for which t is between 0 and 2. Maximum displacement. Okay, so here's the thing. Maximum displacement happens when, okay, let me just show you here. When you take displacement, you differentiate, you get velocity. When you differentiate, and we call this your V is your ds dt. And you differentiate one more time, you get your A, which is your d2s dt squared. So maximum displacement happens when V is 0. But the problem is when you let V equals to 0, there are two values. Sometimes you get one positive, one negative, then we ignore the negative value of t. But here we have both are positive value of t. Yeah, don't need to recalculate because we already have it here. See, by letting V be 0, my t is 2/3 or 2. So similar to differentiation, the chapter differentiation, chapter 2, we have to do second order differentiation to determine whether it's positive or negative, to determine whether your s is minimum or maximum. Because if your d2s dt squared is more than 0, is minimum. If it's less than 0, is maximum, right? Now, we already have our a, or d2s dt squared, right? So maybe I would just take when t equals 2/3, my d2s dt squared, or my a, you can say my a is the same thing. In this case, let's put 6 2/3 inside, u minus 8. This cancel is 2, is -4. So that will give us a maximum displacement. So we say S is max at t equals 3. Now, actually, you don't have to do the other one already. But if you want to validate, okay, we'll do d2s dt squared, which is your v, your a. So let's do one more time.
My special nickname is the Google Assistant.
Now, what we have to do is to put 2 inside. This will give us positive 4, more than 0. Okay, and we say S is minimum at t equals 2. So since I'm finding maximum displacement, so I know I have to take t equals to 3. Now take t equals to 3, sub inside your displacement function. So that will give us the maximum displacement, all right, which is what? Put 2/3 cubic minus 4 2/3 square plus 4 2/3, and plus 2 your c is 2 here, this one. Okay, well, we can use a calculator. It'll make our life easier. Yeah, can't see the, so let me put it here. Okay, so this will be 2/3 cubed. Good. Can I just do mentally? 2/3 cubed is 8/27. All right, then you minus 4, you must times with 2 squared is 4, 3 squared is 9, then this will be 8/3. All right. Okay, and finally you plus 2. Okay, I got 86. 86 over 27. Now we can simplify, change to 3, 5 over 27. 3, 5 over 27. Okay, I like to give my answer in mixed number rather than improper fraction because it tells us that it's slightly more than 3 meter. Yeah, it makes more sense. But I think it's okay to leave answer in improper fraction if you want. Okay, I think this is the last one, right? Okay, if you enjoyed this video, yeah, like I said, you can like, subscribe, and also just so you know that we have lots of material. Yeah, we have the notes and tutorial, topical practice, intensive revision, past year question, drill practice. Yeah, if you're interested to get more practice, right? You can get in touch with us through WhatsApp, visit our website, check us out on Facebook, Instagram, and so on. And also, I've completed this drill practice from 4 book. It's a very interesting, a very good book for step-by-step practice. Yes, for example, you can see an example practices with increased level of difficulty. Together, the best part is it comes with a complete solution. In fact, I've completed the Form 5 version as well. Yeah, it's available for purchase through our Shopee site. Yeah, it's over here. You can find us up, find out more. Yeah, just search for percentage utility, right? Thank you very much for watching. I hope you learned something, a lot of things from this video recording. See you in the next one.